baby. Let's see what we got going on today. All right. I've got a flask over here on the left-hand side. Let's do some acid-base experiments to start off and see what happens with the rest of the live. Okay, here we go. I'm going to add a little bit of universal indicator to the flask over here on the left. And it goes. Look at that. Very nice flow patterns going on. Let me zoom in on that just a little bit. See what we got happening. Yeah, it's a water tornado, Raggles. That's right. Looks kind of cool. You can see it going all the way down to the magnetic stir bar. Now that stir bar is spinning a lot faster than what you're seeing. The frame rate of the camera and the rate at which the spinners going are mismatched a little bit. How you doing there, Antic? All right, here we go. We're going to add a little more universal indicator. There's a little vortex going on here, and you'll notice that the material that I add, it's an acid-base indicator. It stays centered in the middle of the vortex primarily, and that makes sense if you remember. Thanks there, Raggles. If you remember that, you know, the eye of a hurricane is low pressure, and we'd expect the eye, so to speak, of this vortex is also low pressure. And things tend to go from high pressure to low pressure. So any material that's in a low pressure zone is going to stay there. So that's why it tends to stay in that vortex when I first add it. Of course, once it gets down to the bottom and it hits that magnetic stir, it gets dispersed throughout the whole solution. Now what we're going to do, however, is we're going to start adding, make it go faster. You got it. Here we go, right down here. You can see I'm going to turn up the speed a little bit. So that's about 50% speed. We don't want to go in too fast. If I get the stir bar going too fast, it'll knock it out of orbit. Okay, man, here we go. Let's add a little drop of acid to this. Okay, I'm going to add 20% by weight hydrochloric acid. It's the same acid that's found in your stomach. It's just a lot more concentrated, like 100 times more concentrated. In goes the first drop. And you'll notice a color shift to like a, sorry, I'm getting the camera centered here. You'll notice a color shift to like a yellow. That's in line with what we know about universal indicator. Universal indicator indeed changes color with pH. And we do see, well, let me get a little light on the subject here so you can see the pH scale. Oh, wrong light source, sorry. There we go. Let's get this light source over here going. There we go. Right there, you can see, you know, we've kind of like got a yellow-greenish color, which indicates we're below pH 7, but not by much. Thank you there, Antic. The chemical that I'm adding is hydrochloric acid. I'm going to add another drop here. You can see the pH scale down here at the bottom. And you'll notice you first see a reddish color. Happy New Year there, experiment. All right, let's add another little drop of hydrochloric acid. A little more. And a little more. So you can see as I add the acid, the pH drops. So you can see your pH scale here. The topic, Antic, is we just do a bunch of chemistry experiments. And we talk. That's it. That's all we do, man. We have a good time. I think I'm going to try to get the color just a little bit. I want it to pop just a bit more. So I'm going to add just a little more universal indicator. So here we go. A bit more. There we go. That red is really looking nice now. Okay, now, instead of adding acid, we could try putting something in there. Instead of adding acid right now, I'm going to add some base, okay? So I'm going to add sodium hydroxide base. Here we go. Single drop. Well, that was beautiful. Let's add another drop. And another drop. So you'll notice as I'm adding base right here, down here at the bottom, we've shifted the pH from like 3 all the way to 10 pretty quickly. That's a change in acidity, by the way, and proton concentration. 3 to 7, that's a difference of, 3 to 10, that's a difference of 7. The pH scale works on powers of 10, so we changed the proton concentration by 10 million times. Here we go. Let's add some acid. You think I'm antic. You think this is all video effects, huh? Well, I'll tell you what. Tell me something that you think I couldn't possibly do with a video effect, and we'll try it. I don't have any sodium there, experimental. Not here in the... Elsewhere I do, but not here. There we go, baby. Let's see if we can get the rainbow going. I'm going to add a little drop of base here. Here we go. Give me a drop of base. Let's see what happens. Boom. In it goes. Got a little flash of something going on. I think I'm going to need just a bit more acid. Looks like a film, huh? 1, 2, 3, 4, 5. I'm going to go 5 drops of acid. Now we're going to add a drop of base and see what happens. Here we go. 1 drop. Come on, baby. Give me the rainbow. 1 more drop. Let's see if we can get it. Come on, man. 1 more. There it is. There it is. There we had it for a moment. It's always brief. I think it's because the spin rate's a little too high. So it's mixing very quickly. If we turn that spin rate down, we should be able to capture things a little more for a little more longer period of time. There we go. That's kind of beautiful. It's like a orange, red, and yellow tornado. It's kind of like early morning sunrise prior to a stormy day. All right, you can see the vortex up there at the top. Let's add a little drop of our base. In it goes. Look at that beautiful flow pattern. Very gorgeous. I'm going to add another drop. Nice flow patterns happening. Oh, those are pretty. Come on, man. There it is. There it is. We got the rainbow. I do too. I like this. Look at that. Look at that. It's beautiful. Absolutely beautiful. Yeah, that slow pattern's really looking nice. Let's get it acidic again. I'm going to add some drops of hydrochloric acid. Just check out the beautiful flow patterns we've got going on. As the pH drops down here, again, you can see that pH scale. A few more drops here. Agreed, Antic. I agree. Definitely looks like a real tornado. Here we go. Let's add a drop of base. In it goes, and I'm gonna add a second one, and let's just watch. Come on, man. Give me the rainbow. Give me that slow, beautiful rainbow. There it is. There it is. You got violet in the middle, blue on the bottom. I see wisps of green. Yeah, that's pretty. Very pretty. Really cool. Really, really cool. Okay, let's move over to this experiment over here that I got ready. This one over here. Looks like a mixture that's, what's that, green on top, purple on the bottom. Let me give it a mix, see what happens. Well, what in the world? It kind of turned aqua. The thing at the bottom spinning its life away, that's a magnetic stir bar. Would be interesting to hear something about the single die components of the universal indicator and their properties. Let's see if I've got that information with me. I think I do not. But I do know off the top of my head it consists of bromothymol blue, methyl red, phenol red indicator, methyl red, bromothymol blue, phenolphthalein, and the one that does most of the work is thymol blue. All right, you guys want to let's make this bottle together, okay? Let me show you how we can make this particular contraption over here. So what we're going to do, let's take this off, and we're going to explain how this thing works. So here we go. I've got a bottle here, and it's got some water in it. I don't use methyl orange in mine, experimental. There's no methyl orange in mine. There's methyl red, but not methyl orange. Here we go. We're going to add some isopropyl alcohol to this. So I've got water in the container. Here we go. Hello there, Tara Chad. I got some water in this container. We're going to add a little bit of isopropyl alcohol to it. I want to find my funnel. Here we go. In goes the isopropyl alcohol. So I've got a mixture of water, and now we have, that's probably going to be good enough. Water and some isopropyl alcohol together. How you doing? Oh my goodness, Antic. I can't interpret that. I apologize. It's kind of neat. You can see those bubbles rising as the water and the alcohol are mixing. Very kind of beautiful. And now what we're going to do is let's just mix it up. Actually, before we mix it up, let's add a little bit of violet food dye. So I'm going to add some neon violet food dye, okay? This purple stuff. So here we go. In goes a drop of our violet food dye. This usually looks pretty interesting, so we're going to get a little bit more focused in on this. Looks kind of cool, so I'm just going to focus in on the bottle just a bit more. Here we go. One little drop. Boom. Isn't that gorgeous? Isn't that just gorgeous? Watch, look at that. There's like some wisps that are rising and others that are falling. It's a very interesting pattern there. Looks like finger tendrils. Isn't that gorgeous? All right, I'm going to add another drop of the purple food dye, and it goes. Does look a little like a flower. It's gorgeous, isn't it? Absolutely gorgeous. Look at the tendrils, huh? How you doing there, MOH 8346? Great to have you on board. Okay, I'm going to zoom out now, and you can kind of see, you know, as I zoom out, you can kind of tell that there's two layers in the bottle. It does look like seaweed, Antic. So it does look like there's two layers. You can see sort of the alcohol layer and the water layer. And you can tell that the food dye preferentially is kind of staying in that alcohol layer. It does look like a purple flame, Tara Chad, but that might just be staying there because I haven't mixed the two fluids. So let's do that now. We'll do that in a second. We'll do that a different one there, 8346. I'm going to mix this up right now, okay? I just want to give you the idea. So in this bottle, I have some food dye, I have some alcohol, and I have some water. So I'm going to mix it up. You can see that violet color. It spreads, so everything has been transiently mixed. Let's say if it stays permanently mixed. Antic, that's what we are figuring out right now. We are figuring out if the water and the alcohol permanently mix. Now you can see a bunch of bubbles. Look at that. Look at all those bubbles that formed. Isn't that beautiful? It's kind of wild, man. You can see that they're rising. They're rising out of the frame. Oh, but you can see the layers have disappeared. The layers have totally disappeared in this one singular layer. So the alcohol, the water, and the food dye have all mixed. Now what we're going to do, it did look a little like a glitch, didn't it? Now what I'm going to do is I'm going to add salt to this. And when I add salt to this, what's going to happen is the water and the salt are going to be attracted so strongly. Hello there, Slippery. They're going to be so attracted to one another that they're going to push all other stuff out. So that means the water and the salt together are going to push out the alcohol. All right, here we go. Let's mix this up. Again, we see those bubbles forming. But I'm going to give this a good mix. It takes a while because we have to get the salt dissolved. So let's mix this up. Give it a mix. You can see the salt cascading through the mixture. You can also see the reflection of the red experiment over here, which is kind of cool. All right, let's mix it. I should have done some fluorescent dyes, huh? All right, let's mix this up. It's taking a bit. It always takes a bit. We got to really get that salt dissolved. So again, what's going to happen now is the water and the salt, they're going to combine. So 8346, what happens, we have to think about the ionic and molecular level. The water and the salt ions are so attracted to each other that they do the same thing that two people do when they fall madly in love. They attract each other so strongly that they date exclusively. And that's exactly what we're seeing happening in the bottle now. So the water and the salt ions are going to preferentially combine with each other, and they're going to push the alcohol out. So this blue layer down here, where the blue part of the food dye goes, is just salt and water that are binding together exclusively. This layer up here is where the pink part of the purple dye goes. That's the alcohol layer. And in the middle, there's a mixture of all the components. We call that an emulsion. And you can tell, thank you there, Slippery, you can tell that the emulsion is transient. It doesn't last forever. I'll give it a shake again so we can make the emulsion. So here's the emulsion. That's the mixture of everything. Salt, water, alcohol. But this never mixes fully all the way down to the level of molecules. Because what's happening now is the salt and the water, the salt ions and the water, are finding each other, and they're attracting each other, and they're just sticking together like mad. Thank you there, Antic. Hello there, John. They are really sticking together strongly. And because of that, they push the alcohol out. So that all is happening here in the middle, in the emulsion layer. The alcohol is going up here on the top. That looks a little more pink. And the salt water is ending up on the bottom. And that layer is looking a little more blue. I think we could probably add a bit more food dye to this. Let's try that. Let's add another drop of food dye. That's a good question, 8346. I should try that sometime. I'm not sure. I've never done it with, isn't that cool, baby? Come on, man. You can see that the food dye fell easily through the alcohol layer, and now it's slowly finding its way through the emulsion. And it looks like the emulsion may have kind of disappeared. Yeah, all right, let's give this a shot. That was cool. Let's give this a shake. Give this baby a shake. I might add one more. We'll see. Add one more. Shake that up. All right, let's do it. Work fast. Work fast. Okay. I'm going to go ahead and add my drop and see if that drop, see where it ends up. Look at that. Most of it stays right there at the layer of the alcohol. And you can tell it's right there at the interface between the alcohol and the emulsion. And we'll probably watch that layer drop over time because it's resting right on top of the emulsion. So it's at the emulsion alcohol interface with the alcohol layer on top. And then there's the food dye. And then there's the emulsion layer on bottom. And then the blue dye on the very bottom, that's going to be the saltwater layer. It's cool, ain't it? Very cool. Actually, now that you can see the dye is kind of trending behind the layer, the top layer of the emulsion. There's kind of like a cloudy red at the emulsion alcohol interface. That's beautiful. That worked really well. Really kind of cool. Give this another shake. Let that penetrate all through. And get a nice blue color. Gorgeous. All right, folks said they want to try a different color. If we want to do it, we can do the same experiment. I've done it with, could you forcefully add the colors, Antic? Sure, I think I know what you mean there. Let's give it a shot. So I'm going to give it a shake here real quick. And then I'm going to really squirt it in, okay? So here we go. I'm going to really squirt it in hard. This is for you, Antic. Give it a good squirt. Haha, great call, man. Great call. Oh, that was cool. Very cool, man. You can tell I put a heck of a lot of dye in there. There's an enormous amount of dye in the alcohol layer. What you also saw were some droplets. Did you notice those droplets? Those droplets were areas where the I would say the dye was sort of forced into the emulsion layer. It didn't want to be there. Hello there, Syad. Well, Antic, I mean, I had to force it in. What was I to do, huh? Okay, let me give this a mix. This is really going to be deeply colored. And then we can try another color if y'all wish. We can, oh, that's gorgeous. Violet. That's a really pretty violet. I'm going to ask here, what color would you like to see? I'm going to ask a chat question here. What food dye would you like to see? Done. And let's start the Q&A. What food dye would you like to see? Green, maroon. Hey, thank you there, Eon Gamer. Oh, great to hear, Syed. Thank you there, Johnny. Appreciate that. All right, let's look through this. Boy, those colors are really looking nice. So Antic is asking, is food coloring really not a poison? So Antic, here's the answer to that. It's going to be a little. I see all those colors coming through. Let me see this. Let me check out the colors first. All right, Antic, and then I'll try to answer your question. So I'm hearing people want maroon. I do not have maroon food dye. I heard a green. I hear orange or cyan. Blue, cyan, blue, black, green, brown, orange, and black. Whoa, that's a lot of different colors. I heard a lot of blue, and I heard some black. Heard quite a bit of black. I don't have black food dye. But let's set up blue for now, all right? I'll do blue food dye. So we'll set up another bottle. And we'll talk you through it when I do. I'm also going to answer that question, is food dye poisonous? Well, here's the thing about toxicity. This is something you got to always keep in mind when you're thinking about whether something's poisonous. Because guess what, folks? Water can be poisonous. That's right. Well, water can definitely be poisonous. So why is that? Well, if you drink enough water quickly enough, your body won't be able to handle the dose of water that's given to you, and that's going to cause some health issues. All right, I got my water here. I'm going to put in a little bit of alcohol, and then we're going to set this up. And there you go, Tara Chad. So definitely read Tara Chad's comments with respect to toxicity. Everything is toxic. It depends on the dose. And remember, dose is not just amount. Dose is also the time over which you experience the dose. So there's what we call a kinetic aspect to dosing as well. How long and how fast you are, exposed to the particular proposed toxin. Oh, shoot. Where's my bottles of alcohol? I didn't quite fill it all the way. Excuse me a second. I got to find my bottle. I thought I had more. Dang it. I could have swore I brought those down here. I know I have them here, folks. Just give me a second. Where did I put my bottles of alcohol? Come on, man. That's the signal to me that it's time to clean up the lab. Yeah, I got to get these ratios correct or it will not work correctly. So, dang it. Let me give me 1 minute. There's one thing I want to check. All right, I found them. I found it. Sorry about that. I left it on the stair landing to the basement. Okay, yeah, so anytime you hear about something being toxic, there's a couple questions you want to ask. First, let's say they say they find they found mercury in bread. Well, they probably did, because chemists are really daggum good at finding stuff. Like, we can detect things at really, really low levels, extremely low levels. For example, I mean, it's very easy to detect lead in your hair. And, you know, very easy to do, but the amount that's in there is not enough to harm you. So what you do whenever anybody says, hey, we found that, you know, there's a toxic substance that we found in, say, some bread, what you want to ask is, well, how much is in the bread, and how much does it take to hurt you? And you get the answer to those two questions, and then, you know, then you can get an idea of how much of the you know, the bread you can eat on a normal basis. Okay, so here we go. We're going to add the blue food dye. Here we go. In goes the blue food dye. Remember, we have water and alcohol already in there. I'm going to go ahead and take this away so we can see that drop. Look at that. Look at that gorgeousness. Deadly bread. The lead in the bread makes it a leady, deadly bread. Oh. Yeah, lead acetate being sweet is definitely weird. Look at that gorgeousness. Barely related, but I dislike how the red dyes they use on billboards and banners are some organic types that break down eventually by sunlight. Why not use iron oxide? Hey, Universe, I have no idea. What do they break down into? You know, what are the breakdown products? Yeah, I'd be interested to hear that. Look at that flow going up. Looks like live veins that are in our science book. Okay, so remember, in here we have... Yeah, they do. So definitely a lot of dyes are photooxidized for sure. Yep, agreed. Yeah, you're right. That's exactly what happens. A lot of dyes, when they're exposed to light, the light oxidizes them with some UV, and that changes their properties. Okay, here we go. Yeah, red from carmine. There's a lot of places. You can get it from like beet juice as well. What if I drink this? Antic, I imagine the live would end in about 10 or 15 minutes because isopropyl alcohol, that gives you some really bad digestive problems. So I've got my alcohol layer. I've got my water layer, and you can see that the dye is kind of like the same density as the alcohol. Now, if I mix all this up, here we go. Boom, boom, boom. There's the mix. If that blue color persists all the way through the mixture, then we know that everything's mixed. It's miscible, we say. Yep. Everything's all mixed together. It's a miscible solution. So the dye, the blue dye, I don't know, there may be two dyes in here. We're going to find out maybe. The blue dye, the alcohol, and the water are completely miscible with one another. Tasty, all right. All right, now what we do is we're going to add some salt to this. In goes the salt. Now remember, we got alcohol and water in here. When you add salt, I like to say that the salt and the water, the salt ions in the water, date exclusively. Great question, Antic. All right, so they date exclusively. So they are going to be so attracted to one another, the ions and the water. We call it an ion dipole force. So water's a dipole, an electric dipole, and that's going to be very strongly attracted to the positive and negative charges on the salt ions, that they are going to have such strong attractions that any alcohol molecule that tries to attract a water molecule is just going to get set aside. So the salt ions and the water molecules are finding each other and attracting very strongly, and they're basically pushing the alcohol out. Do they get thirsty? Here we go. I wouldn't think fish can see water, but what do I know? I'm not a biologist. Shake this up. Let's see what happens, folks. I think it may be mixed enough. All right, let's see. Let's see if we got it. We do have separation. I can tell we have separation. It's a little tough to see, but you can see right there at the top, you can see it's like clarified, the alcohol layer. Then you have the very bubbly, I should say, emulsion layer. And I'm wondering if the alcohol layer, like the emulsion layer, stops right there. It's interesting kind of the way it's separating here. Interesting. Very nice. So it looks like the blue dye dissolves both in the alcohol layer and the saltwater layer, but it looks like more of it dissolves in the water layer. MTZ, I do have a power supply. Be cool, man. All right, I think we should add a second color to this to see what happens. I think I'm going to add the pink. I'm going to add some pink. All right, so we're going to add some pink dye to this, see what happens. Here we go. Little drop. In goes the pink dye. Looks like it's resting in the alcohol layer. All right, here we go. Let's give her a shake. See what happens. Here we go. That looks like a violet color. All right, let's see. Let's see what happens here. See where that... I remember I added some pink dye. Where's that going to end up? It does look like that, Tara Chad, for sure. Hey, it looked like I just kind of remade the violet dye. Antic, what colors are you thinking? Yeah, it looks like the violet, the pink dye went up here. It's a little more purple than it was before. This is still blue. It's a starry night without the stars. It does look a bit like Prussian blue. Universe wants some yellow. Do I got yellow food dye? I don't know if I do. I don't think I have any yellow. That sucks. I've got like a greenish yellow. Excuse me, a yellowish green. But I do not have any yellow down here. Oh, yeah, I do. Yeah, I do. Yep, I do. All right, we're going to do some yellow. That's the last one I got. We can do some yellow. That'll be the third bottle we do. Hey, kitten, let me show you what's going on here, okay? Let's show you the experiment from the start. So what I have here is a bottle of water, all right? And to this bottle of water, I'm going to add some isopropyl alcohol. So here we go. Let's get it in there. It's my last bottle, by the way. All right. That's probably enough. Now, folks said they wanted to see some yellow food dye. By the way, you see a lot of bubbles form as the alcohol and the water mix. They don't mix completely. You can kind of see there's a layer right there where the two, yeah, they just,